Standard 11 Chemistry Unit 4 Chemical Bonding and Molecular Structure Part 16 Hybridization is to be continued. Last time we had discussed about types of hybridization. Now today we are going to learn about important conditions for hybridization. Here first condition is the orbital present in the valence shell of the atom are hybridized. That means here, for example, carbon and its atomic number is 6. Its electronic configuration in ground state 1s2, 2s2 and 2p2. In excited state, its electronic configuration is 1s2, 2s1 and 2p3. That means here in valence shell there are 4 orbitals 2s, 2px, 2py and 2pz, and they are participate in the hybridization. Okay, so carbon has tetra valency. Second condition is the orbital undergoing hybridization should have almost equal energy. That means here suppose in hybridization with 1s1 here, so hybridize with 2s orbital and the 1s orbital, they have almost equal energy. Third condition is the promotion of the electron is not essential condition prior to the hybridization. And the fourth condition is it is not necessary that only half filled orbitals participate in hybridization. That means here in case 2s, 2px and 2py, 2pz, they have unpaired electron and they are participate in the hybridization. But in some cases even filled orbitals of the valence shell take part in hybridization. Now let's see about the different types of hybridization. First of all, let's see Sp hybridization, or it is named as diagonal hybridization. In Sp hybridization, first of all, one s and one p hybrid orbitals are hybridized and it is called Sp hybridization. That means here its contribution of s orbital is 50% and the contribution of the p orbital is 50%. Okay, so this type of hybridization involves the mixing of one s and one p orbitals in the formation of two equivalent sp hybridized orbitals. Second thing is each sp hybrid orbitals has 50% s character and 50% p character. Now in such a molecule in which the central atom is sp hybridized and linked directly to two other central atoms possesses linear geometry, and this type of hybridization is also known as diagonal hybridization. For example, here in BCl2 molecule, here B and its atomic number is 4, so its electronic configuration is 1s2 and 2s2 in ground state. But whenever it is in excited state, its electronic configuration is 1s2, 2s2 and 2p 1. That means here beryllium has two unpaired electron, one one unpaired electron in 2s orbital and one electron in 2px orbital. Okay, this 2py and this 2pz orbital. Here the beryllium is our central atom, okay. Now for chlorine, here the two chlorine atom, its atomic number is 17. Its electronic configuration is neon 3s2 and 3p5. In 3s orbital paired electron, and here px, py and pz orbital. It is called 3px, 3py and 3pz orbital. 1, 2, 3, 4 and 5. That means here in chlorine atom has single electron or one unpaired electron. Okay, and 2pz orbital. That means here beryllium, which has two unpaired electron, and it is central atom, and the two chlorine atom which has one unpaired electron, and they shares one electron, and the bond is formed, that is sigma bond. Okay, so this is the concept about the hybridization in BeCl2 molecule. Now its shape is linear and the bond angle is 180 degree. Here the example of molecule having Sp hybridization BeCl2 that we have already discussed, and this is the hybridization, and beryllium is our central atom, and here the chlorine atom which has unpaired electron in 2pz orbital, which is, and its orbital is hybridized with the orbital of the beryllium, and it forms sigma bond. Now second easiest method for which type of hybridization is takes place in BaCl2. In beryllium its electronic configuration is 4. That's why here in outermost cell there are 2 electrons, okay, and in chlorine there are 7 electron. That means here Be plus 2Cl, Be has 2 electron and chlorine has 7 electron. 2 plus here 14, that means 16 electron. It is greater than 8 electron. That's why we have to divide it by 8. Means what here, 16 divided by 8, that is equal to 2. Total number of electrons are here 2. That means here our hybridization is Sp hybridization. Okay, now let's see about Sp2 hybridization. In the hybridization, 1s and 2p orbitals in order to form 3 equivalent Sp2 hybridized orbitals. For example, here it is BCl3. For boron, its electronic configuration is 1s2, 2s2, 2p1 1 in ground state. In excited state, here in 2s 2 electron, and px, py and pz orbital, and in 2px only 1 electron. In excited state, its electronic configuration will be this: 1 electron is shifted to the 2py orbital, and now its electronic configuration is 1s to 2s 1 and 2p 2. Now in 2s only this thing 1 electron, and here px, py and pz 1 and 2. That means here boron has 3 unpaired electron. Okay. Now chlorine, there are 3 chlorine atom. Its electronic configuration is neon 3s2 and 3p5, 3s2, and here px, py and pz 1, 2, 3, 4 and 5. Means here chlorine has also 1 unpaired electron. Now how can you easily find out which type of hybridization takes place in the particular molecule? For boron, in valence shell there are 2 plus 1, 3 electron. Chlorine has 7 electron in valence shell. So here in boron trichloride, boron plus 3 chlorine atom, boron has 3 electron, and here chlorine has 7 electrons. 3 plus 21, 24 electron. So it is greater than 8 electron. So we need to divide it by 8. Now this 3, that means here our hybridization is Sp2 type hybridization. This is important for MCQ also. So according to the hybridization, here is boron. It's a central atom, and its hybrid orbitals are in this the orbital of the chlorine atom, and they form 3 sigma bond. Here Cl, Cl and Cl. This shares 1 electron here. Okay, and by sharing of 1 electron they form single bond, and this single bond is sigma bond. So insert here in boron trichloride the Sp2 hybridization is takes place, and the angle is 120 degree. And here the boron has 3 unpaired electrons that we have already discussed in its electronic configuration, and these 3p orbitals, one is 2s and 2p type of orbital hybridized to form Sp2 hybrid orbitals, and 3 hybrid orbitals so form are oriented and is most important trigonal planar arrangement, and the overlapping with 2p orbitals of chlorine to form 3 b bond boron bond chlorine bond, and therefore BCl3 Its geometry is trigonal planar, and the bond angle is 120 degree. Now let's see about Sp3 hybridization. In this type of hybridization, 1s and 3p hybrid orbitals takes place in the Sp3 hybridization. Okay. For example, here in methane molecule, sometimes you will be asked directly the example. For example, here the methane molecule, and which type of hybridization takes place. Here it's carbon, and its electronic configuration in excited state is 1s2, 2s1, and 2p3. 1, 2, and 3 means here four total 4 orbitals takes place in the hybridization. Here the hydrogen and its electronic configuration is 1s1 and 1 unpaired electron, means here the carbon, which has 4 unpaired electron, and the 4 hydrogen atom, which has 1 electron. Okay, here in outermost shell, carbon and the 4 hydrogen, carbon has 4 electron in valence shell, and here 4. That means here total electrons are 8, and we need to, whenever the 8 or less than 8 electron, we need to divide it by 2. That means here 4, total is 4. It means here Sp3 hybridization is the short method. How can you identify which type of hybridization takes place in the particular molecule or ion? Now its shape. Here, for example, in methane molecule, there is mixing of 1s and 3p orbitals of the valence shell to form Sp3 hybrid orbitals of the equivalent energy and the shape. There is 25 characters of 25% S character and 75% P character in each Sp3 hybrid orbitals. Means here we have 4 orbitals, and their contribution is 25, 25, 25, 1s and 3p, that is px, py, and pz. So there each of the contribution is 25%, means p orbital has total 75% character, and the s orbital has 25% s character. Now the, the 4 sp3 hybrid orbitals so formed are directed towards the 4 corners of the tetrahedron shape. The angle between sp3 is 109.5 degree, and here is the shape of the methane molecule. Is carbon is central atom, and it has 4 unpaired electron, and the s is the shape of the hydrogen 1s orbital. It is spherical in shape. That means here there are 4 sigma bond is formed, carbon and the hydrogen, and their bond angle is 109.5. degree. And the another example for the sp3 hybridization is NH3 and the water molecule also. Okay friends, this is the concept about sp sp2 and sp3 hybridization. Next time we will discuss another topic. Thank you very much.